How do satellites perform collision avoidance maneuvers? Have you ever wondered how satellites avoid crashing into each other or space debris? It's a fascinating process that keeps our satellites safe in the crowded space around Earth. Let's break it down step by step. Satellites perform collision avoidance maneuvers to steer clear of potential collisions. The first step in this process is constant monitoring. Satellites and other objects in space are tracked by space surveillance networks. These networks keep an eye on thousands of objects and predict close approaches, known as conjunctions. They calculate the likelihood of a collision happening. When a potential collision is detected, operators receive a conjunction data message. This message provides crucial details about the predicted close approach. It acts as an alert, prompting operators to assess the risk. They analyze the data and refine the predictions about the orbits of both the satellite and the threatening object. If the risk is deemed high enough, a maneuver may be necessary. If a collision avoidance maneuver is needed, the satellite will make a small adjustment to its orbit. This typically involves changing its velocity slightly, which can alter its altitude or position along its orbit. The goal is to increase the distance from the object that poses a threat. These maneuvers are carefully planned to use as little fuel as possible while ensuring the satellite moves outside a defined safety zone around the predicted conjunction point. For example, the International Space Station has a safety box that defines safe distances in 3 dimensions: radial, along track, and cross track. This helps to ensure that the station remains safe from potential collisions. As the number of satellites and space debris increases, these maneuvers are becoming more common. While they do consume fuel and can shorten a satellite's operational life, they are essential for mission safety and sustainability in orbit. To coordinate these maneuvers effectively, operators share their plans with centralized authorities. This helps to avoid situations where two satellites might maneuver into each other's paths. Emerging technologies, including automated systems and machine learning, are being developed to make collision risk assessments faster and more accurate. Some future systems may even allow satellites to autonomously decide when to perform avoidance maneuvers while keeping ground operators informed. In summary, collision avoidance maneuvers are vital for managing the busy orbital environment. They protect valuable space assets and help reduce the creation of additional space debris. By understanding how these maneuvers work, we can appreciate the complexity of keeping our satellites safe in space.